Good afternoon. On today's Angry Bulletin, scientists would have us believe that Mars, lacking a significant magnetic field, provides little or no defense against cosmic rays and solar radiation. Therefore, any astronaut exposed to a significant solar storm or even just everyday radiation on the Martian surface is going to be a dead man in very short time. And there's no way to really defend against this. Well, as I think you're going to find out soon, this is completely false. All this and more coming at you on the Angry Astronaut right now. Good afternoon and welcome to another episode of The Angry Astronaut. Today I'm going to be quoting extensively from a paper entitled Radiation Shielding Approaches for Planetary Surface Exploration, a Mars Case Study for University of North Dakota Concepts by Arturo Ortiz. And this paper is almost 10 years old, so it's not like we didn't know all of this stuff about Mars before. All of these articles have been published about how colonizing Mars is going to be impossible because of all the horrible radiation. But it's interesting to note in the introduction of this paper that even without shielding, the Martian atmosphere provides significant protection against things as violent as a solar storm. A number of scenarios are presented in the paper where an explorer might be, for example, inside a lightly shielded mobile habitat while they're out exploring at 0 kilometers altitude. So in other words, the Martian equivalent of sea level. Then an intermediate scenario entails the same conditions, but with a solar flare occurring while the astronaut is outside at about 4 kilometers altitude and protected only by his spacesuit fabric, which, by the way, provides virtually no protection whatsoever against solar radiation and cosmic rays. And the more extreme scenario involves a climbing expedition where the astronauts are at the top of Olympus Mons. Now, once again, if we review what we've always been taught about Mars, well, without the magnetic field and with a very thin atmosphere, you would think that the radiation would be roughly the same in most of these scenarios because there's no magnetic field, very little atmosphere, so it should be about the same as being completely unprotected in outer space. But here's the situation. At 0 kilometers, the astronaut would take 270 millisieverts, which is a significant amount of radiation, but not fatal. At 4 kilometers altitude, 337 millisieverts. Again, this is from a full-fledged solar storm. And then finally, when they're on top of Olympus Mons, when there's virtually no atmosphere at all, it's 1196 millisieverts, which is enough to give anybody radiation sickness, also known as acute radiation syndrome. Even though a human being can absorb more than 1,000 millisieverts worth of radiation in their lifetime, or even perhaps over the course of an entire year, taking this much radiation in one dose is enough to kill you, or at least to get you very, very sick. But again, my point is, look at the colossal difference between the amount of radiation that somebody's going to suck up if they're at an altitude of 4 kilometers or so, as opposed to the top of Olympus Mons. We're talking a difference of nearly 70%. And that means that the Martian atmosphere actually does provide a considerable amount of protection even without any sort of shielding. And again, this is during the most extreme type of solar event that we can imagine. A mega solar storm where somebody is unlucky enough or stupid enough to get caught in the open. But what happens if we add some sort of protection to all of this? Well, there's a wide variety of different types of shielding that are explored in this paper, and all of them look really effective. First of all, if we just just want to, say, bury ourselves in Martian regolith or bury the habitat in Martian regolith? Well, they determined that a meter or so of regolith is more than sufficient to provide complete protection against just about anything. But if you're facing a scenario when you don't have an entire meter of regolith piled on top of you, well, it's important to know what sorts of materials provide what sort of protection and what exactly you're protecting yourself against. What kinds of radiation are astronauts really going to have to contend with in interplanetary space and also on the surface of Mars? Well, first of all, let's go ahead and talk about the solar wind. That's something, of course, that the sun is continuously emitting, consisting mainly of protons and electrons. Now, the solar wind intensity varies over an 11-year solar cycle with a range of about 10 billion to 10 trillion particles per cubic centimeter per second. So that's a very, very big difference between a low and high period of solar activity. Generally, solar wind particles have very low energies and are easily stopped within the few hundred angstroms of shielding material. So during what's called a solar particle event or a solar storm, the sun releases large amounts of energy in local bursts of gamma rays, hard and soft X-rays, radio waves, and highly energetic particles, mostly protons, and dynamic magnetic fields in the solar corona accelerate these particles into interplanetary space with energies on the order of several gigavolts. So we are talking about enormous amounts of energy compared to the ordinary solar wind, and therefore SPEs or solar particle events can deliver enormous amounts of radiation in a very short time. And this is by far what's going to be the most dangerous thing to astronauts, either in interplanetary space or even on the Martian surface, regardless of how much protection the Martian atmosphere provides. Now, galactic cosmic rays are very different. They are not individual particles like electrons or protons. They are instead ionized nuclei of elements ranging all the way from hydrogen to uranium. Galactic cosmic ray ions have energies from several tens of millions of electron volts per nucleon up to 1 trillion million electron volts per nucleon. They are unbelievably powerful. The more abundant elements in galactic cosmic rays, hereafter referred to simply as GCR, are hydrogen through nickel with energies of tens to millions of electron volts. Still very, very energetic. From interstellar space, the nuclei approach the solar system and they interact with the heliosphere. Galactic cosmic rays are highly penetrating and are going to create a great majority of the radiation problems on the surface of Mars, assuming that you're not in the middle of a solar storm. But how serious is the problem really? Well, let's go ahead and check out the Curiosity radiation readings that have been taken since August of 2012 to try to get an answer, because prior to Curiosity, a lot of the assumptions that we were making about Mars was flat out wrong. We believed erroneously that the radiation levels on the surface of Mars would be about the same as the radiation levels in the depths of space, and frankly, it just isn't. According to the measurements taken by Curiosity, the dose rate is about 210 micrograys per day. What does that mean? Well, 1 gray is about the maximum that you want to absorb, at least over the course of a single year. And you probably don't want to suck up any more than 4 or 5 grays over the course of your entire lifetime. But 210 micrograys per day adds up to less than 1/10 of 1 gray for an entire year, which means you would need to stand unprotected on the surface of Mars for over a decade before you would really start running into any sort of significant health problems. And again, that's unprotected. Now, of course, if you include solar storms in that equation, it changes things quite significantly. But as long as you can be shielded during those solar storm events, we actually don't need to look forward to an environment on a Mars colony to where everybody has to stay underground and hidden away most of the time in order to avoid long-term radiation sickness. So what kind of shielding makes the most sense? Well, I hate to break it to you, SpaceX fans, but things like stainless steel or aluminum are not necessarily the best kind of protection, because even though a dense metal will definitely stop a highly energetic particle, at least a great deal of the time, when those particles strike the metal, they actually create a reaction whereby new radioactive particles are created, and those particles bombard the passengers inside the ship. And that's going to be the case on the surface as well. You don't want metallic habitats. At least that's not what you want to use for your radiation shielding. The type of material that produces the least amount of reactions when you have energetic particles striking it is something that's high in hydrogen. That, of course, would be water, but also polyethylene. And so what the researchers of this paper recommend is that the habitats that the University of North Dakota were designing be coated in an armor of at least 5 grams per square centimeter of polyethylene. And this could increase to as much as 15 grams per square centimeter. But of course, that much polyethylene is going to increase the weight of your habitat significantly. And then you pile more regolith on top of the habitat in order to give you even more radiation protection. And then they did some studies in terms of the radiation levels that they are likely to experience on Mars, both from galactic cosmic rays and also intense solar storms, to determine just how bad things might get for astronauts on the Martian surface. So let's have a look at some of these graphs. First of all, the external environment, as you can see, that's the dark red or dark brown, whatever line that you want to call it there on the graph. You can see that the radiation is colossal for this situation because that's the external environment. No shielding means a lot more radiation, especially during a solar storm. But then if you just add 5 grams per square centimeter of polyethylene, it drops off the amount of radiation considerably. And then 1 meter of regolith, well, that's the orange line across the bottom of the graph. 2 meters of regolith makes it even better. You're looking at the blue line at the very bottom of the graph. Indeed, habitats protected by this much regolith would absorb about the same radiation as the recommended maximum for nuclear plant workers. In other words, a very, very safe level of radiation. However, keep in mind, those statistics are only for the solar storm. In addition to that, you have to take into account a whole year's worth of galactic cosmic rays, and those things are very, very insidious, especially if you're at higher altitude. So here's a graph for GCR and what the impact would be with various levels of protection. And as you can see, even 2 meters of Mars regolith does not provide complete protection. And also, as you can see, altitude makes a massive difference here, depending, of course, on your level of protection. Again, indicating that the Martian atmosphere really does have a significant impact on the levels of radiation that you're going to suck up over the course of an entire year. So if you're talking about the external environment, once again, pretty damn nasty over the course of an entire year. You're looking at galactic cosmic rays approaching maybe 0.4 of 1 sievert. Again, that's not nearly lethal, but still not something you want to be sucking up year after year. But if you take it all the way down to a polyethylene protective bladder and also 2 meters worth of Mars regolith, then even over the course of an entire year, it's just 70 95 millisieverts, about 3 times what nuclear power plant workers are recommended to take per year, which is a very safe level of radiation. So over the course of 10 years, you're probably not going to be running into very significant risks if we're talking about radiation problems. 1 meter of regolith, well, it gets a bit worse, although still not horrific. Again, we're talking about people who are going to be spending their entire lives on the surface of Mars. And also have a look at how much the radiation drops off in most of these scenarios if you're down at -5 kilometers elevation. In other words, at the bottom of the Valles Marineris. In that case, you're taking at most maybe about 100 millisieverts worth of radiation per year, 1 sievert per decade. That's not going to be enough to really cause serious radiation sickness anyway. It's definitely going to be an increased risk for cancer, but we're only talking maybe a 5% chance or something like that over the course of your entire life, something that will ultimately be a problem for Mars colonists, but still not nearly the lethal killer doses of radiation that all of the articles that we read about the surface of Mars would lead us to believe. However, I don't want to paint a completely rosy picture here. Let's have a look at a scenario where you don't have all that regolith piled on top of you. Let's say that you spend a year out in the field inside a habitat that provides 10 grams per square centimeter worth of polyethylene shielding, and that's about it, and you get hit with a full-fledged solar storm plus the average galactic cosmic ray exposure during that time. Well, depending on what your elevation is, it could get pretty damn nasty. We're talking maybe a third of a sievert total during this time, way more than you want to be taking. If you take that much radiation exposure within about 3 or 4 years, it's going to start getting a little problematic, and you might want to go back home, assuming that you'll be able to, given the gravity differences between Mars and Earth, but we'll talk about that in a different video. Still, you can see the big differences that exist if you don't have all that regolith providing the protection. By the way, we're not even going to talk about how bad it would be if you didn't have this type of protection. And again, if you look at what the levels of radiation and exposure are, if you are, again, at the bottom of the Valles Marineris, not really that bad. Total exposure of about 150 millisieverts, even without the Martian regolith. So the key to surviving on Mars is going to be having a good sense of timing. In other words, go outside when the radiation really isn't as problematic. You don't want to go outside or away from your best quality shelters if there's a full-fledged solar storm going on. But if you manage to do those sorts of things, hide in your shelter when things are dicey, and then come back out the rest of the time, there's a very good chance that you could live out a very full life on the surface of Mars without any real significant health problems. But it's also going to be location, location, location. As much as scientists have told us over the years that Mars' atmosphere provides no protection from radiation whatsoever, that just isn't true. We were wrong about Mars again, and we've known this for over a decade based on the data that we've gathered from the Curiosity rover. The lower you are altitude-wise, the better you're going to fare, and the fewer climbing expeditions that you make to places like Olympus Mons, the longer your life is going to be. Now, of course, is living on Mars going to be as easy as living on Earth? No. Space is hard. Mars is going to be hard too. Is it going to be as hard as space? No, I don't think so. Radiation levels are not nearly as bad, and there's a lot of in situ resources that we can exploit in order to make living on Mars a lot easier. Most significant of which is going to be water. I mean, hell, there's so much water ice on Mars, especially in the areas that we're thinking about setting up a colony in the Valles Marineris, that we could have swimming pools, ponds, that sort of thing in the long run, depending on how big our colonies are, and the surface features of Mars, the natural wonders that exist on this planet, from the Valles Marineris to the impossibly tall volcanoes that exist on this planet. I think it's enough to keep any human being occupied for the rest of their life. Thank you very much for watching. Please don't forget to like and subscribe, and also please check the description for various ways to support this content. And thank you so much for 35 million views, such an incredible milestone that we just passed. This is my final video in this trilogy of videos to celebrate this particular event. Thank you so much for being loyal viewers, and as always, stay angry about space.